Hello. In the last lecture, we have covered how to do data analysis with Google Engine, and we cover how to do zonal statistics with a feature collection and also an image. For example, calculate the mean elevation of every US state. We also talk about how to do zonal statistics by group. For example, how to calculate the total area of each land cover type in each US state. There's also some other things that, for example, we can calculate zonal statistics with two images. So for example, sometimes you might want to calculate, for example, the elevation, the mean elevation of every land cover type in this case. So you only deal with two images. You can also utilize the zonal statistics, image stacks by zone. Then you can also calculate. I'm going to skip this one because it's less common. Also, there's map algebra, basically do mathematical operations with two images or one images, depends on which data you want to use, and you can write an equation to that. I'm going to skip these sections because we're not using this in the lab assignment. Also, there's a section about working with local geospatial data, raster data, vector data, and this is very much similar with the leaf map. So we have covered this one in chapter 14 about how to visualize local data with leaf map. So Gmap is pretty much the same. So you can visualize all kind of vector data, raster data. You can also do some data conversions between different vector formats, and also cloud optimized GeoTIFF, spatial temporal X catalog. So I leave this to your own like practice. You can try out those source codes, should be pretty much the same as the leaf map. And in today's lecture, we're gonna cover how to export data. This is a very important one because after you do the computation, eventually you might want to export the data outside from Google Engine so they can use in desktop GIS, so we can use the data to create some maps. So we're gonna cover this one, how you can export images, basically the export vector data and raster data from Google Engine. So from here, I'm gonna switch to my Jupyter VS Code. And so first, let's talk about how to export images. You can export one image or you can export multiple images. Depends on the data you want to get. So specifically for this example, I'm going to show you. This is a landscape imagery covering California, and this is an entire landscape scene. And for this image, it actually has um, multispectral bands, but I only select three spectral bands: B5, B4, and B3. So basically near infrared, red band, and also green band. So you can select just the three spectral bands and then you visualize that. So this is surface reflectance, right? So you can see here collection 2 on top of the atmosphere, and you can specify the minimum, the maximum, and then you can visualize the data. So if this is the data, for example, you want to export, you can export the entire image or you can export just a subset of the image. So in this case, I'm just going to maybe add a rectangle. So this is just a bounding box, a B box of the lower left corner and also upper right corner. So you'll be, for example, here, this corner, longitude, latitude, longitude, latitude. Once you have this geometry, then you can add this geometry to the map. So just for demonstration, I'm going to export this data. You can use the Gmap function export image, and then you can pass in the image object. So this one is the entire image, and this is the output file name, and also the spatial resolution. So 30-meter resolution, and also the region. So the region is this one. So this yellow bounding box. Again, you can export the entire image, but Google Engine only allows you to export data directly to the computer if the file size is less than a couple megabyte. So that's why we just use this one to show you, see how it works. And once you run this one, it's going to generate a URL, and Gmap is going to automatically download the data from the URL. So once you have this, you see it has been downloaded to my computer here, and you also have this one, like landsat.tiff. So this is imagery that we just downloaded it, and it's a small file. So if you try to open it, you cannot open. You need to use desktop GIS to open. You can also use um, Gmap to add the raster data to your computer if there's something you want to do. So I'm going to, for example, add this one to QGIS. So I'm going to open the file and then I'm going to go to the book and then Geospatial. So it'll be this one, right? So I'm going to drag to the desktop GIS, zoom to the layer. So take a look. Pretty nice. It's very clear. So this is the 30-meter resolution, but we only export a subset, right? So it's not the entire file. And this one is 10.9 megabyte. So it's a small file. It should only have 3 spectral bands because we only select 3 spectral bands. But if you select more bands, then the file size will be larger. And you might run into error. So if you try to download the entire image, it may not allow you. In this case, if I remove this one, for example, I remove the bounding box and you try to download the entire image and they see what happened. It's going to say an error occurred while downloading. Total request size, blah, blah, must be less or equal than. So you can clearly see here, this is like 8 digits and this one is like 9 digits. So it's so much larger than the limit. So this is why you need to reduce the file size, either have a coastal solution. For example, if you download in Taiwan, maybe you need to change to maybe 90 meter. 90 meter might even be not enough, right? So you can maybe change to, I would say maybe 150. How about this? Okay, 150, it's fine. So basically Google Sensing allows you to download data directly to your computer, but it's usually for small file only. If it's a large file, then it's not going to work. Okay, so right now this one is 11.4 megabytes. So you can see you can download it, but the resolution is going to be way cost, and this is not ideal. Later I'm going to show you how you can export the data in native resolution, for example 30-meter resolution. But this is one thing you need to pay attention. So basically if you want to export data direct to the computer, you can export the small pieces. And so this is just a landscape imagery. Sometimes if you try to download multiple images, the data you downloaded, they might not align perfectly with each other. So similar in this case, for example, let me zoom in here. And if you pay it, certainly this is different resolution, so it doesn't, it looks pretty much the same because it's the same image. Anyway, so if you try to download multiple images, sometimes the pixel doesn't align with each other because they basically if the image want to align with each other, need to make sure that the same resolution. You also need to make sure they use the same transform, because if in the upper left corner of the imagery is different between images, you might end up with some mismatch. So in this case, you can just get the resolution. For example, I can calculate and you can figure out what's the CIS, especially the coordinate reference system for the image, and also the CIS transform. So in this way, you can get the CIS and transform. When you export the data, you can specify the CIS and transform. If you don't specify, Google Sensing is not going to calculate this one automatically, and this is why you sometimes have some the images do not align with each other because the CIS transform is mismatched. So if you want to precisely align multiple images together, then you probably want to specify this CIS transform. So you might have different images, so you will need to use the same CIS transform for different images. So in this way, you can export all the data directly with the same CIS and CIS transform. So when you open in desktop GIS, they will align with each other. Okay, so this is something you definitely need to pay attention. And so this only shows you how to export data directly to your local computer. Again, it's very limited because you can only export anything 10, 20 megabyte is fine, but larger than that, you won't be able to do that. So the alternative is to export this one to Google Drive. So what you can do is just to use the function export image to drive, and then for example image. So after you run this one, it doesn't show you anything. Then you need to go to um your Earth Engine JavaScript code editor. Then you need to see, for example, um the status. So let me show you. So I may not have this one here. Let me move to the other window. And so once you log into your JavaScript code editor, let me show you here where it is. So this is, once you log into your JavaScript code editor, you will see I'm exporting the images. This right now we're trying to export. Is it the entire image? Yeah. Oh no, not the entire image. Still just a small subset and 30-meter resolution. If you can see from here, it might take a couple seconds. So if you are trying to export large image, then you definitely need to use this one. Otherwise, you won't be able to read. So if the file exceeds, for example, 20 megabyte or something, you want to export to Google Drive because this one allows a large limit. So you see, it's done. Then you can open in Drive and take a look. It might take some time to appear. I take a couple seconds. This is actually the images that I downloaded previously. So I can delete all of them, run this one, and then maybe delete all of this. It might update the date right now is still not updated yet, but if you wait for a couple minutes, you will see it should be reflected as the latest one. So what you need to do here is to make sure that you specify the folder, right? So this is the export folder. You can specify to any folder you like. If you don't specify, you will use the root directory, right? So right now it's under my export directory, and then you have this file, and this is why it's working here. All right, so this is how you export to Google Drive. There is another function called download image. So this one allows you to download the entire image. They exceed the Earth Engine limit. So if you need to download large data directly to a computer, this is kind of a workaround. So under the hood, it's going to download small pieces simultaneously and then merge those small pieces all together as the large one. So for example here, in this one, you need to install the dependency GEDIM. So on the right here, take a look. So this is like 7.9 megabyte uncompressed, and we're downloading the name all at once. So once you have that, let's take a look. So now you have this, see, 2.5 megabytes. So it's certainly larger than the one that we downloaded earlier, and it's high. It's 30-meter resolution, right? So again, I can check this one to here. So this one is 30, no, it's 90-meter resolution, but you can certainly download the original one. So if you want, you can change to 30-meter. It's going to be taking a longer time, so I can try it out in here. This one is 715 megabyte, so uncompressed, and you can see you can still download it. Again, under the hood is downloading those smaller pieces together, subdivide the image into smaller tiles, and then download all the tiles together. After that, it used raster IO to merge all the images together as a single one. So if you want to download large images, so directly to a computer, this is something that you might want to use. And it's basically just a workaround. It's a hack. So it's no guarantee that it will work in the future because Google might not allow you to do that in the future. But at least for now, it works just fine. So let me see the image now. So see, 374 megabyte, and we can load it and we can compare with the previous one. You can see the differences, right? So right now this is so much better, much higher resolution compared to the 90-meter resolution, right? So you can certainly see the differences. Okay, so this is how you can download a single image, just a single one. If you have a collection of images, so if you want to download multiple images all together, you can also use Gmap. So I'm going to show you this one. I'm going to use the USDA map imagery, high resolution aerial imagery, and then cover this particular intersecting with this location. And also I'm just going to select that images with the near infrared band, so it's consistent. So if I run this call, you can actually see how many images in there. In this case, we have 7 images intersecting this particular location. So this is basically an image collection. So you can think about it's a directory contains a bunch of images. So we have 7. So when you're trying to export, there are multiple ways you can export. You can export directly to your computer. So this one you can use export image collection, and then you pass in the image collection and the output directory. So right now we're trying to download it directly to our computer. So output directory, a period means it's like the current directory, and the scale equals to 10. That means it's 10-meter resolution. This image is actually a 1-meter resolution, so it's much higher resolution, but you don't need to run one by one, so I can download all the images all at once, and you should be able to see right now, right? We have these 7 images. It's pretty small, and it's only 10-meter resolution, so I can drag all of them to the map, and you can take a look at the data quality, right? So this is 10-meter resolution covering North Dakota, and you can turn layer on and off. Right, so it's pretty good quality images that's free, available on the Google Sensing platform. If you want to download, for example, the original 1-meter resolution, it's recommended that you export to Google Drive. So I can change this one, and then I can just export this one to Google Drive if we send all the requests to Google Sensing. So I'm going to basically run this one. Here, it doesn't show you anything, but under the hood, it's going to send the request to Google Sensing. And after that, you should be able to see that one from your JavaScript code editor. Take a look. So it automatically pop up. So now we have 7 images waiting to download to your Google Drive. And again, this is suitable when you're trying to export large images exceeding the Google Sensing limit. And you need to wait. After it's done, you're going to find those one in your Google Drive, just like what I showed you earlier. Yeah, it's done pretty quick. So now I can open in Drive. Take a look. So it's here now, and we have this image 1.6 megabytes. So you can download it to your local computer, or you can download directly. And there's also the same similar function, egmap.download image collection. So this one is kind of also the workaround, and also allows you to actually export images. So I can write I forgot what maybe the collection, and then outdoor 10-meter resolution. I'm not sure if the correct parameters. No. Okay, yeah, it works just fine. So it's just the same. But I can certainly export to, for example, 1-meter resolution. You can use a higher number. The file size will be larger, so you can still download it directly to a computer, and this is pretty nice. So you output to a directory. So now I have this, right? It just replace all the images. So these are the 2 ways that you can use to export images, or a single image or image collection. Next one, feature collection. So sometimes you might also want to export vector data, and so in this example, we're going to use the US state boundary. So for example, I'm going to use Alaska as an example here. So this is just one polygon, and it's a feature collection, right? Even the feature, it's a feature collection with just one feature, one polygon, Alaska. So when you're trying to export the data, there are a couple ways. Depends on the data format you want to use. I can E to SSP. That means I can export as a H3 shred file. So I can run this one. Then you have this one. See here, all the data directly, Alaska. Download it, or you can use E export vector. So this one you can basically use any data format you want. So you're going to infer the data format based on the file extension. So here, because you're using .ssp, under the hood is going to run basically E to SSP. So this one is more general. You can, for example, export to a geo package, for example. Then under the hood is going to convert to a geo package. Or you can also export as a GeoJSON. So just like this, alaska.geojson. Or you can export as a CSV. So if you don't need the geometry, you just want the attribute table, then you can export to as a CSV. Also, if you want to do data processing, you can XE to GTF. So in this way, you have the geodata frame, then you can use the geodata frame in your workflow, and you can use it for computation rather than writing the data to your physical hard drive. And so the geodata frame allows you to actually visualize the data using, for example, gtf.explore. Not Explorer, Explore. Right, so under the hood is going to use volume, right? So you can visualize the data just like in here, and you can see all the attributes are also available. Sometimes if the geometry is very complicated and there are lots of points, exceed the file limit, you might want to just export the data frame. So in this way, you don't have the geometry. So this is much smaller. And once you have this, you can easily just DF to CSV, for example. Then you can save this one as a CSV. So I'm going to say Alaska CSV index equal to false and run it. Then you should have the CSV downloaded to your computer. And as I mentioned earlier, just like when you are exporting images, so vector data is also, if you try to export directly to the computer, it only works for small data set. So if the data is pretty big, like you have a large vector data set, you better export to your Google Drive. So it's going to use export vector to Drive and then give the feature collection you want to export. And this one will be the task name, right? So when I export this one, it's going to send to my Google Drive, and you can specify the file format. It's HTTP means that actually straight file. You can export as GeoJSON. I think there's only the two format. You can also export as KML or KMG, and this is the directory where it's going to export to. So again, you need to use the JavaScript code editor to see that, right? So I'm going to come here and then maybe refresh, and then the task. All right, it's done. It's pretty quick, like less than 1 minute. So this one we are exporting as H3 straight file. So this will be the file format in here. And once you have that in your Google Drive, you can download it to your computer. Use that for visualization or analysis. Okay, so this is what I want to show you, how to export Google Sensing data using GMap. So you can export images, you can export a bunch of images automatically, or you can export vector data. So what I recommend is to finish all your computation, you only export a small subset rather than the entire data set. So they can save you a lot of time. Okay, so this is all for this video. I will see you in the next lecture.